All right, so in this module, we're going to be talking about syntax of propositional logic. So if you remember this diagram, what we are going to be talking about in this lecture is thinking about syntax of logic, thinking about semantics of logic, the meaning of logic, and in addition to that, thinking about inference rules, how can we manipulate logic? And one point I want to mention is, like, you might have seen logic in other classes, you might have seen logical formulas and being able to manipulate them and move things around. And that's not really the point here. The point here is to have this general framework, kind of like this more principled way of looking at logic, where we can think about algorithms that can manipulate logical formulas and can do inference rules just more generally from an algorithmic perspective. So the point is not for you to be able to like do logic and move things around. The point is to have an algorithm that algorithm can do logic. Because the goal of this class is to have an artificial intelligence that can do similar things as how humans would do it. So the point is not for you to do logic. The point is for the AI to be able to do logic. And this is kind of like an analogy to that is thinking about the Bayesian networks lecture, right? Like last week we talked about Bayesian networks. And in that setting, right, like you might be able to do conditional marginal probabilities perfectly fine, right? You might be able to manipulate things perfectly fine, but that was not the point. The point was not for you to do that. The point was to have an algorithm, maybe like gift sampling, that is more generally can be applied to any Bayesian network, not like a single example. So we're basically trying to do a similar thing in the space of logic here. Okay, so let's talk about syntax. So what is syntax? So the syntax of a propositional logic consists of a few different things. So it consists of propositional symbols. So these could be like A or B or C, like these take Boolean values. And then based on these propositional symbols, we can basically build formulas on top of them. The propositional symbols are also commonly like known as atomic formulas. And then you can make more complicated formulas based on these atomic formulas using a set of logical connectives. So these are negation and or implication or bidirectional implication. Okay. So let me actually write that here. So we are going to start with syntax. So what does syntax have? So syntax has propositional formulas, propositional symbols, sorry. So these are like A, B, C, and so on. And then we can have formulas defined on top of them. And let me use F for formula. And how do I define formulas? I use these logical connectives to create formulas, these connectives that we just talked about. Okay. So like here are a couple of examples of how we go about it. So we can build these formulas recursively. Let's call F and G formulas here. And if F and G are formulas, then I can even build more formulas on top of them. So I can have negation of F as a new formula, or F and G as a new formula, or F or G as a new formula, F implication G, or F bidirectional implication G. So like F is equivalent to G. You can think of it like that. Okay. Here are a few examples. So if A is a Boolean symbol, A is a formula by itself. Negation of A is a formula. Negation of B implying C is a formula. So I've just used a bunch of connectives and created a more complicated formula here. I can have this guy as a formula, right? So negation of A is a formula, negation of B is a formula, negation of B implying C is a formula, negation of B or D is a formula, and then or of these and of these is also going to be a formula. Okay. Negation of A is a formula. Well, why is that? Because A is a formula, negation of A is a formula, negation of that is also a formula. And this guy, A negation B, is not a formula. So why is that the case? Well, negation of B is a formula, A is a formula, but A and negation of B are not connected with each other using any logical connectives. So this is just basically putting two Boolean, two logical formulas right next to each other without any connectives, and that's not a formula. A plus B is not a formula. Well, why is that? Because plus just doesn't have any meaning. Like doesn't have, like the syntax of it is not defined here, right? Like I never defined plus, and that doesn't have that doesn't make sense in this logic. It's not defined in this language. Okay. And one other point I want to mention here, and we'll talk about semantics soon, is that syntax here, you can think of it just as symbols. Like syntax, it doesn't have any meanings, right? Syntax is just the symbols that we are using here, and with no meanings assigned to it. And the job of semantics is to assign meanings to what does negation mean, actually, or what does implication mean, like what would be the meaning of it. But when we're talking about syntax, I could use any other symbol. I can use this symbol, and I can just define that in my logic, and that would be the syntax of my logic. So don't assign any meanings just yet when we are talking about syntax. It's just symbol manipulation when we are talking about syntax, right? But next, in the next module, we're going to talk about semantics and giving some meanings.